Welcome, welcome, one and all. My name is Mary Bellard, and I'm joined today by John Campbell, Wendy Chisholm, and Kartik Sawhney to talk about accessibility innovation, which for good reason is oftentimes a race with no finish line. We're delighted to share with you a sample of projects using Microsoft technology. At the end of the presentation, we'll list all the websites and resources that we mentioned about to make it easier for you to learn more. The course, if you will, for finding out where advancements in technology add value in society begins with people, real people with disabilities that encounter all kinds of scenarios throughout their day-to-day lives, from using voice input to control a device to detecting objects in a photo. The opportunity and expectation of technology is set by you. These scenarios lead to experiments to test an idea, not being afraid to fail, research, iterating until we get it right, and design, of course, plays a key role in development. And for the most applicable ideas, perhaps something gets released to the market, where consumers discover the true utility of a product. For today's discussion, we'll talk a little bit about products, a little bit about experimentation, but mostly we're going to talk about research. Not everything we discuss today is available. For the most complex opportunities, years of research can be needed to truly understand how to efficiently design and develop a piece of software or hardware. There's lots to be done, lots of questions still to answer. After this intro, John is going to discuss the latest in eye tracking research. We'll give you an update on the AI for Accessibility program. Wendy's going to talk about mental health research, and then Kartik is going to demonstrate how AI can be applied to a real-world scenario. And we'll close with some high fives and next steps. So let's get going. On the market today is Microsoft Soundscape, a mobile app that uses 3D audio cues to enrich a person's awareness of their environment. It helps build a mental map of your surroundings while you're navigating, which can be particularly useful for people who are blind or low vision. Now, Soundscape even supports Bose frames, giving customers a wearable to improve hands-free use and raise the bar for future audio augmented reality experiences. Products like Soundscape and Seeing AI are a great example of what's possible when technology is created by and with people with disabilities. And improving access to education now will ensure disability talent remains at the core of innovation in the future. Code Jumper is one of the research projects that addresses that opportunity. This hardware kit offers a physical programming language designed to teach basic coding concepts to children ages 7 through 11, regardless of their level of vision. These pods are each tactily unique, and they represent a line of code. And when you string them together into the hub, you make software. This was developed by the Microsoft Research Lab in the UK in collaboration with students who are blind. And this work is now on the market thanks to the partnership with the American Printing House for the Blind. Hardware kits with software are available in the US, UK, Canada, and Australia, along with a full Microsoft Educator community course and curriculum. All the details are at codejumper.com. I also want to talk about that experimentation piece I mentioned. Hackathons are a playground for experimentation and innovation. For 3 days each summer, Microsoft employees are asked to stop doing their day job and to go do something else. The something else that many people choose to work on are projects related to accessibility and disability. These efforts are part of what is called the Ability Hack. Each year, employees are involved in projects across disability segments. And this past summer, we even had our first mental health hack challenge. One of the projects that came from this was an adaptation of Minecraft called the Mindful Night, which aims to help young people develop social and emotional skills. You can check out the interactive world today and even get a content pack for educators to guide students through exercises in self-awareness and coping skills. Another research project to mention is our exploration in sign language recognition and translation. We had hosted a 2-day workshop on our campus with experts from the global sign language research community. Attendees represented multiple domains, such as deaf culture, computer vision, natural language processing, linguistics, and graphics. Sign language recognition is an exciting topic because it pulls from multiple areas of artificial intelligence or AI. It's not just about computer vision and tracking hands. Sign language is so much more than just hand shapes. And it's not just about grammar and vocabulary either. It's really a combination. After the workshop, the group summarized our findings into a research paper. It's an honor to share that this work received the Best Paper Award at the Assets Conference back in the fall. Leadership and involvement from the deaf community in this work is what makes this research possible. If you're interested in reading more, check out the workshop site that includes a link to the publication at aka.ms/sign language. We will keep you updated as this research progresses. To keep on the research not yet in the market topic, let's check in with John on eye tracking explorations his team is going after.
Thanks, Mary. So in order to look forward towards eye tracking's future, we should quickly look at their past. So eye tracking has based around three main techniques. The first is direct observation, basically looking often through a translucent panel to see where someone else is looking. The second is a scleral coil, basically a contact lens with some wire inside it, and then a wire coming out from that contact lens hooked up to a bunch of equipment. That's great. It's the gold standard because it's so accurate, but it's not really practical for accessibility scenarios. The third and most common is iris center corneal reflection, basically looking at the glint in your eye in comparison to where your pupil is located, and then doing a bunch of trigonometry to figure out where you're looking on a screen. Eye tracking is not really just one monolithic unit. It's actually a stack of components built on top of each other. And our team has spent a bunch of time looking at the entire stack. So we've worked at the application layer with Eyes First Games and hands-free music. We've worked at the speech and device control layer with Eye Control for Windows. And we've also worked at the hardware interface layer with the HID interface specification that we developed with a number of third-party partners. Today, we're going to talk about Rgb eye tracking. So why Rgb eye tracking? Well, from a limitations perspective, the current eye tracking solutions can be very expensive, and they also can be hard to obtain. And once you do obtain them, they can be hard to configure. They're also not readily available on most consumer devices, so that limited install base can cause limitations in innovation because people just don't have them available to try. Rgb eye tracking has the potential to solve many of these issues. RGB cameras are a great opportunity because RGB-based web cameras are built into many consumer devices already. Beyond that, if you need to buy one, they're relatively inexpensive. And many consumer devices are starting to have deep learning processors built in to their devices. In 2016, MIT released a paper called Gaze Capture relating to how you can use an RGB webcam in order to do eye tracking. They really showed for the first time that webcams were viable methods to do eye tracking if applied via deep learning. Now, deep learning is a very complex topic, and there's lots of nuances. But at the highest level, the way that eye tracking can be done with an RGB camera and deep learning is this. You take an image, you find the face using face detection, and then you split that face up into component parts, 2 eyes, and then the overall face image itself. If we feed those into an algorithm, along with some other metadata, lots of processing occurs, and then eventually what you get on the other side is an XY coordinate for where the algorithm thinks you're looking. Now, one of the important things, especially at Microsoft, is that we want to make sure that deep learning algorithms can be understood so you can root out biases and other issues. So our team has been focusing on interpretability as well. So this is an example of how we can interpret what the model is seeing. So in this case, we have an image of an eye, and as expected, there's a lot of activity highlighted in yellows and oranges and reds, indicating that the model cares a lot about the eye itself. That's what you'd expect. But what's interesting is you see that there's a hot spot around the eyebrow as well as on the lower edge of the eyelid. And that makes sense from a physiological perspective because those muscles are activated when you move your eye in certain directions. But the trigonometric models that look only at the pupil and the iris would not necessarily pick those up. So it's an opportunity for computer vision in order to improve accuracy. This example is one output from our algorithm. So we have a gentleman looking at the screen, and the dark red crosshair is indicating where he's trying to look, the stimulus, if you will. The green crosshair is what our algorithm indicated where he was looking. And you can see it's relatively close. There's always going to be error in these sorts of systems. The yellow circle indicates the range of where a commercial eye tracker indicates where he was looking. using infrared, which is the current state of the art for most consumer devices. So in this particular example, our algorithm is actually doing better. Now, that's not always the case, and this is early stage research, but it is an indication that we're on the right track and that this is potentially viable. As we look to the future, one thing we do have to worry about, though, is biases and other issues that can come up when you're specifically dealing with accessibility scenarios. One particular case is people living with ALS or other complex rehab scenarios often need things like CPAPs, BiPAPs, trach, or ventilator solutions. Those can interfere with face detection. So in these images, you can see Stephen Hawking. The first image, you can see his head is tilted slightly. That doesn't fool the face recognition algorithm. And so you see the red dots indicating that it's found all the parts of his face. The image next to it is still Stephen Hawking, and to a human, the image looks very clear, but the face detection algorithm has failed, likely because of the extra switch that comes off of his glasses is obscuring parts of his face. Below, you can see an image of Steve Gleason, and that was also able to successfully be detected with the facial recognition software. But in other scenarios where they're using a partial face mask, it might fail. So we have to make sure that whatever face detection algorithm that we use coming into the system is well suited for people with disability-oriented scenarios. Back to you, Mary.
Thanks, John. Super exciting. With all the possible scenarios that exist with devices, it's not realistic that any one company is going to be able to demonstrate all that is possible with today's technology. Global opportunities are best addressed by a global community. As part of Microsoft's AI for Good initiative, alongside AI for Earth, humanitarian action, cultural preservation, and health, our AI for Accessibility program is getting researchers, developers, makers, and students access to our Azure platform to imagine the future of accessible technology. In building out the program, we needed to be realistic that the unemployment rate for people with disabilities is more than double the rate for people without a disability. That only 1 in 10 people have access to the assistive technology that they need, and that access to communication is critical to so many parts of society. It was from those truths that we identified 3 focus areas for the program: employment, daily life, and communication and connection. In our next section, we'll learn from Wendy about additional investments the AI for Accessibility program is making and what our team is prioritizing for the year ahead. We'll also have the opportunity to get insight from Kartik on how AI applied to a real-world scenario can elevate the possibilities. Now on to Wendy.
As Mary said, we have 3 focus areas: employment, daily life, and connection. And we're looking at funding projects across 6 disability segments. Those segments are mobility, vision, hearing, neurodiversity, speech, and mental health. We're also looking at the intersectionality between them and projects that may span across all the disabilities. Well, in the first 18 months of the program, we hadn't awarded a single grant in mental health. And that's very disconcerting for us as a program, because within Microsoft, we have a very vibrant internal employee community of people with mental health conditions. And worldwide, we know that 1 in 10 people have been diagnosed with a mental health condition, and that's likely low, and it's likely to increase, especially with the pandemic. We know that there's been a 70% increase in the number of people taking an anxiety screen from Mental Health America, their website, and a 64% increase in the number of people taking a depression screen. And that's just between January and April. We also know that there is a lot of stigma, and that even when people need help, they don't always search for it. Stigma can really prevent people from reaching out and getting the help they need. In addition, even when someone is ready to reach out for help, it might not be there. In some countries, there is only 1 mental health worker per 100,000 people. So there's a really big gap here. While we do not want technology to replace mental health professionals, we were looking at, can technology help the professionals scale? And in cases where it makes sense for a person to talk to a peer, can technology help build those bridges and find the best people for people to talk with? So we were really excited about what we did. We issued a request for proposals. It was the first time that we did a very specific request. All of our application deadlines have been open to whatever people want to submit. And it was different for our program to reach out and specifically solicit specific researchers and ideas and to see what we got. And we're really excited of all the applications. We were able to award 3, not nearly enough, but that's what we were able to do. But what we're hoping is that now we've established a pipeline so that we can continue to get these great applications and this great research in mental health, and we can continue to award projects moving forward. So I'm really hoping to see more of those mental health applications coming in. When we look to what's coming up, our next application deadline is July 30th. We're going back to an open call. We will accept applications related to any topic, any disability or combination of disabilities, and any of the 3 focus areas. When we look to December 15th, we're going to issue another specific call. This one is for smart cities and transportation. Transportation is another area that before the pandemic, there was already many barriers for people to get to work, get to the grocery, get to school. It's going to be interesting to see how the pandemic, and as we start traveling again and returning to the workplace, what transportation looks like, how will it change, and how can we ensure that those changes will be inclusive moving forward, and how can technology help? So we're excited about that specific deadline in December. Looking further, on March 12th, 2021 is another focused application deadline. This one is about education. And I'm excited to hand it over to Kartik, who will tell us more about AI and how his project is influencing education and AI. Kartik, on to you.
Yeah. Thank you, Wendy. So hi, everyone. I'm Kartik. I work as an AI scientist on the Cortana team here at Microsoft, our personal assistant. And I'm also the co-founder of iSTEM, where we work to empower students and professionals with disabilities using AI. So this past year, they were super excited to receive the AI for Accessibility grant in collaboration with Enable, which is a nonprofit working with blind and low vision students in Kenya. And we are working on a project called iAssist. And to give you some background about that, in developing countries, a lot of students who are blind or visually impaired still do not have access to technology or computers. And so they still use test readers and writers for taking their exams or for completing assignments. But that actually poses several challenges. First, it's often hard to find qualified test readers and writers when you need them. But not only that, especially with higher education, as you take more specialized courses that have specific terminologies and domains, it's often hard to always expect your test reader and writer to be familiar with what is being tested, the specific domain terminology, the symbols on the exam, and so on and so forth, which sometimes negatively impacts student performance. So we wanted to develop something that would provide students with a similar interface that they're used to, so a natural conversational interface that they have with their test readers and writers, but that could be automated using AI. And that is where Project iAssist comes in. It's basically a conversational agent, so like a Cortana for taking your exams or for dictating your assignments. Except that you can not only just dictate it, but also navigate through the document using the same kinds of queries that you would use with a human being, with your test reader or writer. Whether that is to go to a particular question or skipping a question, marking the question for review, what have you, doing scratch work, all of that being taken care of by this agent. And the way we do this is, of course, there are several components to it. And as you can imagine, one of the components is speech recognition, where you want to take in what the person is saying and convert that into text that can be processed. But again, we have to account for specific terminology corresponding to that exam, which is why we use custom speech recognition to train our models specifically on the content that is being tested to increase the accuracy of our speech recognition system, but also, of course, any other domains that specific models that we might want to train based on what is it that they're doing. And once we're done with this, the next component is the language understanding component, where you want the computer to understand what is it that the person is saying and converting that into something that it can then process and execute an action on. So for example, when someone says, go to question 5, or a variant of that query, how does the computer understand what the person really means? How does that map to a particular action? And how does the computer actually go ahead and execute on that action? And that is where the concept of intents and slots come in. So in classic language understanding, an intent is basically an action that you want the computer to take. So that action could be going to a particular question, or marking something for review, or skipping something, or maybe perhaps deleting something. And the slot is a parameter that the computer needs to know to be able to execute that action. So, for example, let's go back to our going to a particular question example. The computer wants to know, okay, well, what question do you want me to go to and read? And so that particular question number is the slot that helps the computer take an action. To help the computer understand and convert it into this language of intents and slots for it to execute these actions, we have to start off with a data set. And the data set is essentially a bunch of queries that we expect the people to say with their specific intents and slots. In other words, the queries being annotated. And so this data set is often either crowdsourced or this can be synthetically generated. So in our case, for example, we started off with just 500 queries that we thought were representative of the various things that the people might say while interacting with this agent. Of course, we are now working to expand the size of our data set. But once you have this annotated data set, you now move on to training your model. And there are various ways to do that. A lot of the classic models, they would actually use feature extraction, where you would specifically define like various features that you want to extract out of your data set, whether that is converting your individual words into the vector space, or it's bigrams, which is 2 words at a time or 3 words at a time, etc. Or it's deep learning, where you don't necessarily have to explicitly define very concrete features. It's a lot about it learning itself through layers, what to make of what features can it automatically extract. So that is what we're using for our language understanding effort. And once we have the model ready, it's packaged, then you can expose it through an API. And the API is basically what now helps your software to interact with this model and to get the predictions based on what the person is saying. So for example, we have logic defined for how does someone go to a particular question, what should the computer do, and how should it read it out when we receive a particular intent and slot. So this mapping is there from like an intent slot pair to an actual action or a function, which is what we get using this API, the prediction that we want the model, the software to use, or your execution to use. Super excited about what's coming. We are doing fairly well in some of these algorithms, but of course, this is preliminary research. So a lot of work to do to make it product ready, to make it usable for others. A lot of new things coming in terms of just robustness and being able to handle a lot more queries than just the simpler queries. Super excited about what's next to come. But yeah, I'll pass it on to Mary now to take it forward.
Thanks for sharing, Kartik and Wendy. I also want to highlight our most recent webinar on the Microsoft Ability Initiative at the University of Texas, which is a grantee in our AI for Accessibility program, where they're leveraging the VizWiz data set of images captured by the blind and low vision community. And they're hosting a data challenge to build out algorithms to predict accurate and useful image descriptions. The webinar is available now, and the data challenge deadline is June 1st, 2020 for submissions. And it'll all culminate in a workshop as part of the CVPR conference. Encourage you to participate if you're interested. As promised, on our second to last slide, we have all the resources linked that go into more detail on the projects discussed today. Thanks to each of my fellow presenters, John, Wendy, and Kartik, and an extra big thank you to all of the people behind the technologies we discussed today that trusted us to represent the work. There are many years of ideas, experiments, and customer feedback in these projects. We still have so much further to go and so much more that we could talk about. We hope you learned something new and enjoyed getting the sample of innovation in accessibility. We've definitely had fun getting to talk to you about all these research projects and consider it a privilege to be in this race alongside you. Thanks for being you.
Q.
Alrighty, thank you everyone so much for attending this accessibility innovation presentation, Race with No Finish Line. Once again, I'm Mary. Wendy's not able to join us for the Q&A. She's she's having fun in another session right now, but I am joined by my fellow presenters, Kartik and John. Thank you both for being here. We have some questions submitted by the audience prior to today, so we'll run through a few of those. But I wanted to start, given that it is the 10th birthday of the Ability Summit, I wanted to ask each of you what your favorite birthday memory is, whether it has to do with the Ability Summit or not. That's totally cool. John, we're going to start with you. What is your favorite birthday memory?
Sure. So my wife, a few years back, before we had kids, we went up to the San Juan Islands and we did this like whale watching kayak adventure. We didn't end up seeing any whales, unfortunately, but we saw a lot of other cool wildlife. And so it was just kind of a nice, chill way to enjoy the outdoors.
Very cool. And Kartik, what about you? What is your favorite birthday memory?
Yeah, so nearly 3 years ago, my family flew down from India for my birthday, and somehow they managed to keep this a secret. And so that was really exciting. And they booked a ticket to Vegas without me knowing it. And so being able to spend the day with them in Vegas was awesome.
That's really cool. Very, very cool. For me, favorite birthday memory, probably, I think it was my 27th or 28th birthday. My mom wanted to, do something special, and she was asking me what I wanted. And growing up, our family was very big into like playing cards, like poker and May I and everything. And so I asked if we could go over to one of my grandma's house and just do like a card night. And so that's what we did. We ordered pizzas and we all just played cards till wee hours of the morning. And that's definitely one of my favorite memories. So thank you for sharing those birthday favorites. To go into the content from this presentation, we had one question submitted that said, as Microsoft continues on the path of accessibility innovation, when will access technology merge with universal usage technologies like keyboardless computers or AI all-purpose screens? Kartik, do you want to take a stab at this one?
Sure. So I think we're already starting to see some of that. And I can speak to my experience working on the Cortana team, which is our personal assistant, where, so speech and audio, for example, have been a part of a lot of assistive technologies, except for perhaps some of the scenarios, for a very long time now. And for a very long time, we've been thinking about things like, okay, how can we make blind and visually impaired more productive through speech? What can we do? What kind of feedback could we use? And if you think about it now in our world of assistance, that's actually becoming ubiquitous, and we're thinking about how can we make people in general more productive when they use a lot of these speech experiences. And so we're already Can you hear me?
Yes, we can.
Oh, sorry. Okay. Okay. Some of the things that we've been thinking about, specifically in the assistive technology realm, are now becoming universal. With we thinking about a lot of these issues from a productivity perspective for everyone. So I'm already seeing a lot of convergence in this space, and as we innovate more and more, I expect this to be even more in the future.
Very cool. I mean, I think the inclusive design principle of kind of design for one and extend to many comes out mostly in this question and the examples that Kartik provided. I'd also add even, captions. When you look at the stats around the number of videos that are played on social media platforms, as an example, with captions on, thinking about friends of mine, whether they have a disability or not, using captions as a convenience, really, and that is going to continue. We also see features like dictation, people using it for disability scenarios and not, and read aloud, being able to have text on your screen read aloud to you when you're in the browser or in a Word document. All of those are examples where the disability or accessibility scenario is the core, and there's value in other extensions of that experience. Thanks for that answer, Kartik. We're going to switch over to John. We have a series of questions all related to eye tracking. The first one, John, was, can eye tracking be used to play video games?
That's a great question. Yeah. So we're already seeing that today. And so the Eyes First games, which Satya mentioned in the keynote, are a good example of that, where they're dedicated to sort of disability scenarios. We also see some movement in the sort of the mainstream gaming space where people have adapted certain games to be enhanced by eye tracking. So as with most games, once you have the game itself, you just decide, do you want to use mouse, keyboard, joystick, and then eye tracking is just yet another input. I think the really interesting part of this is once it becomes a user experience problem, not a hardware limitation, is how do you adapt that game? And that's a tricky one. So for example, if you've got a game like Street Fighter, which you have to do lots of complex button combinations in order to pull off a move, that's going to be really tough with eye tracking. However, there are games like Shenmue or Dragon's Lair, which have taken some of those complex interactions and boiled them down into a single button press to still create awesome effects. And that's a good example of how you could adapt a game to a input like eye tracking, where it would still be a super fun experience.
Awesome. And the eye tracking research that you talked about today, is that related to the hackathon back in 2014? Is it separate? Can you talk a little bit about the relationship there?
Right, yeah. So we started from a hackathon back in 2014. I was lucky enough to be on that team. And we had a lot of challenges that came directly from our users, specifically Steve Gleason, among others. And so a lot of the stack that we talked about earlier in this presentation was addressing many of those direct needs. So how do I improve my speech? How do I improve my interactions with my family and friends? That sort of stuff. As we've worked on in this space, we've found other problems sort of lurking beneath the more obvious ones. And this Rgb eye tracking is trying to address one of those lower level problems. So we're still working on the same goals, but we're just also extending beyond that initial set.
All right, keeping with the eye tracking topic, the Rgb eye tracking research that you mentioned, is that meant to replace how we understand eye tracking today or complement? Can you talk about that?
Yes, that's a great question. So I think it's good to look at the parallel with another technology that most of us are familiar with, which is webcams. So 20 years ago, webcams didn't really appear in most devices. They were a separate add-on, they were expensive, they weren't very good quality. And then over those past 20 years, we've seen them integrated into more devices, they're higher quality, that sort of thing. And then today, you've got pretty good cameras in most devices, and they serve most people's needs. And we sort of think of them as being free because we already pay for the device and they come with it. There's still scenarios where you want a better quality webcam. Maybe you're doing streaming or that sort of thing, making YouTube videos. And in those scenarios, you're going to want to pay for a better quality camera for a variety of reasons. I think eye tracking is in kind of that same place that webcams were 20 years ago. There are a couple devices that have eye tracking built in, but not many. And so it's still kind of hard to get, it's still kind of expensive, still can be hard to configure. But if we can reduce that barrier to entry such that more people have eye trackers, and Rgb eye tracking is a great way to try and reduce that barrier to entry, then we say, well, great, there's a good enough solution for a lot of people, and in a perfect world, it's free because it's using hardware you already have in your devices. Then you get that good enough solution for a lot of people. And then yes, if you have a specialized need that needs that higher accuracy, then that would be a place where, yeah, go buy the more expensive one that has better capabilities. That's the way many markets work.
Great. And the last question on eye tracking, you know, we think that emotions, happy, sad, angry, etc., impact the shape of your eye. So how does eye tracking handle emotions like anger? So
I think that's something that we still need to do a lot of research on. One of the things I mentioned earlier in the presentation was about interpretability of machine learning models. We don't want to just take a bunch of images and say, well, it worked, good enough, right? We want to understand what those biases are. So that heat map that I was showing, yes, it can interpret some of those more subtle muscles in your eyes. That could be for good, it could be for bad. So we sort of believe that there's mostly good there, but it's also something that we want to make sure we have the tooling to be able to check that out, as well as a really diverse data set so we can understand, like, just because you're angry, that shouldn't mean that you're staring at the wrong button, that sort of thing.
That makes sense. Kartik, we're gonna switch over to you. I like this question a lot. What is it like working in accessibility at Microsoft?
I think this is a perfect time, an amazing time to work in accessibility, given the potential of AI and all of that you can do to try and innovate and think of new solutions. And in particular at Microsoft, it's really exciting because you have access to the state-of-the-art research coming out of MSR and other product groups in the AI space, and then you can build on top of that and adapt to a lot of the accessibility scenarios. So there's a lot of support, a lot of collaboration, and then also in particular when you think about like the hackathons that we have where employees from across the company are excited to work on accessibility with you, and a lot of ideas come from them as well. So I think from a collaboration perspective as well, it's really exciting at the company, and it's amazing to see the interest that people have in the space, but also the scale. I think the scale is really awesome as well. I for example, back in 2015, when participating in a hackathon, was working on what is now Seeing AI. And little did I know that in a short period of time, it's actually going to reach so many people. So I think scale, impact, and collaboration, all of that is great to see at Microsoft in the space, and it's a really exciting time to be working on accessibility here.
Absolutely, and in that same hackathon in 2015 for Seeing AI, that's where Kartik, you and I met for the very first time. So here we are today. It's a good networking opportunity. Great. We have another question about innovation and like where things are going. John, I'll switch over to you. When would you anticipate access innovations merging with sort of a standard human interface?
Sure. So I think we're sort of seeing that today, and Kartik did a good job touching on it a little bit. So voice interfaces used to be dedicated, for those that were using them day in and day out, really more of an accessibility scenario, things like Dragon Naturally Speaking, that sort of thing. But over the past few years, we've seen voice interfaces in our cars and in our homes really becoming mainstream. And so that really helps everybody. Looking towards the future, I think we're going to see that same thing happening again. Previously, we had this viewpoint of a sort of a diagnosis-based view where we said, well, you are this because of your diagnosis. And we know that that's not a really good way of looking at things. We're people first. And then we have different capabilities that we have and then we need to adapt to. And especially with the emerging view that aging is a polydisability. So because of that, we're all going to have different capabilities. And what we need is we need software and hardware solutions that can combine and adapt in novel ways to make sure that each of us can have the right software, the right hardware at the right time to meet our needs.
Great. We had a question for Wendy, and I'll do my best to represent her on this. What does it mean for AI to be used in a mental health scenario? So I think that there are two different areas to think about. One is language, and then the other is data and identifying trends with that data. Within language, we think about crisis lines and online peer support groups. And how can AI features like natural language processing, how can that maybe surface relevant resources as someone is talking about a particular topic, describing a particular scenario, what resources are available, how to get access to professional mental health individuals like therapists or psychologists. And then on the data side, we also think not just about the customer who's pursuing their mental health journey, but also the professionals that work in mental health. How can data from their patients that the patients choose to share, how can that supplement and complement the in-person relationship between a professional and their client? So there's a lot of opportunity. It's very much a new area of AI, but it's certainly one that the AI for Accessibility program is thinking through. And then our last question to wrap it up, we'll go around the room again. What's the thing you're looking forward to the most in accessibility? Kartik, we'll just start with you.
Sure. I'd go back to what John was just talking about, right? Where people have different, different experiences, different needs, and it is important that our technology is personalized. And so, what I'm looking forward to the most in accessibility and assistive technology is this personalization. for example, I'm a data scientist and I deal with a large amount of data. And let's say that I like to navigate that data in a particular way. Can my screen reader learn my patterns, from my patterns, infer how I like to do it, and then provide me that experience? Can it automatically tell me, using some feedback, what are the anomalies with the data? Or let's say I'm using some sort of a navigation app and it knows from my calendar that I'm going to this building and I've never been to this building before. Can it automatically guide me, right? So a lot of those personalized experiences that are inferring from my activity and really are learning the way I like to do things and the way things work for me, and then providing me those experiences, I think is going to be super powerful and strong.
Love those ideas. John, what about you?
It's really kind of the same thing. We're very much on the same wavelength. I look forward to this sort of input fusion in the future where switch and speech and eye tracking and mouse and keyboard and really any input that you have merges together in a seamless way. So I don't have to have one tool interfering with another tool because you happen to have multiple needs based on you being a human being. And then the other thing is, I look forward to having those accessibility tools travel with me across devices. So when I get in my car or when I go to my phone, I don't have to reconfigure everything from scratch. That it sort of knows these are the right settings to travel with me, and those ones were specific to the desktop or specific to the phone.
Awesome. I'll echo all of those points, and I'll add in one other: more disability innovators. That's what the accessibility community needs. There's so much talent in the global disability community that we know that there are so many great applications of technology to empower all of us to do more. And so I will leave you with that. Thank you so much for attending our presentation, joining us with this Q&A. Thank you to Kartik and to John. Enjoy the rest of your summit. Check out our deck. It has a list of all the resources on that second to last slide that we mentioned throughout. Enjoy the rest of your Ability Summit, everybody.